Hi everybody, welcome to my video on factoring a greatest common factor from a polynomial or a GCF instead of greatest common factor. The first thing we're going to do is we're going to talk about what a factor is and what a product is, because these are going to be really important words as we move through. Factors are the terms being multiplied. So in any multiplication problem, the two things being multiplied are always factors. Product is the answer to the multiplication problem. So in this example, negative 10x is a factor. 6 minus x is also a factor. And negative 10x squared plus 60x is the product. That is the answer to the multiplication problem. Today, we're going to take our first look at factoring. We are going to be taking a product and we're going to be breaking it into the factors that make up that product. And in order to do that, we need to know what a greatest common factor is when we're dealing with polynomials, with these larger expressions made up of multiple monomials or multiple terms. So a greatest common factor, this is a big definition, is the largest integer and highest degree of each variable that will divide evenly into that polynomial. So we're going to start by looking at the numbers. Then we're going to look at the variables and find the largest integer and highest degree of each variable that will divide evenly into that polynomial. So let's take a look at a couple examples so we can really break down what that definition means. I'm going to make this a little bit bigger. So our first example is 7x squared minus 21x. The first thing we want to look for is the largest integer that will divide evenly. Well, the greatest common factor between 7 and 21 is 7. So that's going to be my largest integer. After that, we're looking for the highest degree of a variable. In this case, I have x squared and x to the 1. There's a secret 1 there that we've talked about before. Well, the biggest degree that fits into both is 1. So our greatest common factor is 7x, or 7x to the 1. Once I divide out 7x to the 1 from both of these terms, I'm left with my other factor, which is x minus 3. And that's how we're going to factor a greatest common factor in expressions. In my next example, my largest integer that divides evenly between 18 and 12 is 6. And my largest variable, the largest degree of a variable that will divide evenly into x to the 6th and x to the 3rd is x to the 3. So my greatest common factor is 6x to the 3. When I divide 18x to the 6 by 6x to the 3, I'm left with 3x to the 3. And when I divide 12x to the 3 by 6x to the 3, I'm left with 2. In example 3, we're going to look at both of these terms. Well, this term doesn't have a coefficient. It has an invisible 1, but that means that we're not going to have a whole number here. But they do have a variable in common. They do have an x in common. So our greatest common factor is going to be x. When I divide each of these terms by x, I am left with 5x. X divided by x is not 0. So we're not going to just leave this as 5x. X divided by x is actually 1. So this is x times 5x plus 1. 9x plus 45 is our next product that we're going to factor. Here, they do not have a variable in common, but there is a greatest common factor I can pull out of 9x and 45. That greatest common factor is 9. So my factors making up 9x plus 45 are 9 times x plus 5. Last but not least, let's factor 15x to the 3rd minus 25x squared plus 55x. Although this has 3 terms, we're not going to factor it any differently than we were factoring the binomials before. The greatest common factor of 15, 25, and 55 is 5. And the variable with the highest degree between x to the third, x squared, and x that divides evenly into all three is x to the 1. Remember that invisible 1 with that x. That means our greatest common factor is 5x, or 5x to the 1. When I divide 15x to the 3 by 5x, I'm left with 3x squared. When I divide negative 25x squared by 5x, I'm left with negative 5x. And when I divide 55x by 5x, I'm left with 11. So my factors are 5x times 3x squared minus 5x plus 11. Let me know if you have any questions. Thanks so much.